Hi, it's John from the Machine Shop. I thought I'd just give you a quick look at a little project I've been working on. It's a motor driver controller. The idea is it's quite a small, these small size motors. This is a tiny little motor, and it's a LiPo battery motor driver that allows a soft start and a soft stop with different speeds of the motor that you can select with the switch. So I'll just go into Arduino and I'll take you through the code. So at the start we define all of the input values. So that is the motor, the USB power, the low battery, the push button, and the 3 switch positions. I'll describe what they are in a minute. We set up a couple of variables at the start, and then we also set up a couple of settings or parameters that we need. So in the setup, we then set up all the pin modes as to whether or not they're outputs or inputs, or they're inputs with pull-ups. We also set up a serial port. And in the main loop, the way we do it is we first start off by determining finding out what speed we want to use. So in here, I've got it down as, because these use an 8-bit digital to analog converter for the pulse width modulation, the biggest number we can get is 255. So if you're in the high speed setting of the switch, then that takes it up to the maximum speed, so that's full amount of power. If you're in the medium, 200, and if you're in the low, 150. So then the idea is you've got a push button to start it and to stop it, and then you've got the switch to select what speed you want to do. So the push button basically says, because the push button is set up as an input with a pull-up, that means if you've got nothing connected to it, it will give you a high all the time. So when you're not pressing the button, it'll be high. So the little exclamation mark there means when you're not pressing the button, or when you're not, it's the inverse basically. So when I do press the button, right, and I'm not in any sort of ramp up, or no, sorry, that's ramp. Yeah, when I'm not in ramp up, and when my period is set to 0, so that is if I've got a time frame of this much, then how do I describe it with my hands? Let's say, for example, if I wanted to be, this is my time frame, right, and it does this time frame every single time. If my period is a line in between that time frame, if it's set to be on for 50 and then off for 50, that means you're at half the amount of power. If I'm at 100%, then it's all the way across, and that's 255. If you remember the speed settings, 200, then you'd be looking at the 55 off and the 200 on. And then, yeah, that's how you work out the period. So the way it does that is, so then if I press the button, it enables the ramp. So that ramps up. It sets the period to the minimum that the motor needs to start running. So up here, we set this here, the minimum that it needs to meet. So this motor that I've actually got here, which I'm testing with, it needs at least a period of 150 to actually start. So if you were to start it at 0, it would squeal for a long amount of time before it starts actually turning and then getting up to full speed, if you want to get up to full speed. So that's that part. And then we also set a timer. I'll tell you why in a minute. And then if I press the button again and it's at full speed, whatever your max speed was depending on your switch, then that'll start the ramp down. So that's where it says ramp equals 0. So then we've got this soft start feature. So that essentially says that if I'm in ramp up and I haven't got to the maximum speed yet, then keep ramping up, ramp up even more. Else, if I'm in the ramp down and I haven't got all the way down to 0, then keep ramping down. And it does that by basically changing that period from being, if it's at full, going until it stops. And if you're at the other end, it goes right, it will start at 150, whatever your minimum was, and all the way up to the top, to the maximum, if you've got it set to full speed. Then what I've also put in here is like I said, it needs a minimum amount, otherwise the motor's not doing anything but it squeals. So what I've done is, when you do the ramp up, it will start at that minimum number and go up to the maximum speed that you want it set at. When you ramp down, it comes from the maximum speed down to that minimum number and then turns it off, and it stops that little section there of squeal. So that's that bit there. And then the other feature is a 35-second timer. So what that does is, back up here, it actually grabbed whatever the millisecond timer was that's built into the controller. And what this does is, if that timer expires, turn the motor off. We've also got a bit of power protection here. So I'll show you in a minute the actual breadboard. We've got a LiPo battery. They're very sensitive. And also the charging circuit, it doesn't like it if you're drawing power from the battery and trying to charge it at the same time. It messes with the algorithm on the charging. Not cool. You could end up overcharging the battery, which will make it blow up. Likewise, you can not undercharge, but you can use too much of the battery. A LiPo battery works basically when it's fully charged, it's at 4.2 volts, and when it's flat, it would be at 0, but that means it's dead. So really, you want to go between 4.2 to about 3 volts. At 3 volts, don't use it anymore, leave it at 3 volts. So you sort of charge in between that, you don't go below 3. So what that does is it actually reads, I've got an extra couple of wires which comes from the charger to say, I'm on USB power, don't use the battery, so it turns it off. And also, if I've got a low battery, turn it off. So what that does is that literally just says, right, motor off, kill it, and it then resets all of the variables. Otherwise, tell the motor to turn at whatever we have our period set at. So if you're in the ramp, then it would be ramping up, or if you're at maximum speed, you know, whatever. And then what I've also done is a little bit of debug, so it just, as I'm coding, I can see what it's doing so that I know I've got the right settings. I've also got a delay in there because otherwise you'd never see the ramp. It would go so quick that it would just go and it would just be on. So there's a little delay in there just to allow it to actually perform that ramp. Which I'm actually just going to quickly change that number because I've just remembered that ramp speed is what I want to have that set at. So ramp speed. So what that actually does is it grabs this number from here, and I want that set to 10. There we go. So when if I've got a different motor, for example, then this number would change, and depending on the size of that number and depending on how fast I want it to accelerate, then that would also change. So if I find that I've got a motor which starts spinning at 50, then I may not want such a high acceleration time, or I may want it longer, whatever I want. So that's the code. So let's go over to the breadboard and I'll quickly take you through it. Okay, so we're over here on the breadboard. We've got our small motor here. We have here an Arduino Pro Mini. Over here we've got an Adafruit Power Boost 500 LiPo charger. We have a MOSFET which allows the power to go to the motor. That's the push button there. I've currently got, with this white wire here, that is actually the switch. It's just hardwired at the moment and it's set to its maximum. And then that's the LiPo battery in the background. Yeah, that's fine. So then what I can do here is, I don't know if you just about see that motor working, you might be able to hear it. So currently it's sat waiting for someone to come along and press the button. So when I do press the button, you might just be able to hear that motor moving. If I bring the microphone, you might just be able to hear that motor spinning. Now you may have heard a little, that's just that motor starting up. So that's where the period is increasing. So now if I press the button again, it stops. So if you can hear that, it's now nice and quiet. Now I've also got, turn it on, this is where that timer kicks in. So we've got a 35-second timer. If that exceeds and I don't press the button, then the motor will ramp down and stop. So we'll give it a few more seconds. It's still going. I don't know if you can actually see the motor spinning. There's a tiny little, oh yeah, so it should ramp down very soon. There we go, and it stopped. That was our 35-second timer. And then there's also the feature of when you press the button and for some reason I plug the charger in, so I plug my USB charger in, the motor has immediately stopped. So that's gone. Okay, charger's on, I won't take any power from the battery. So now what's happening there is the Arduino is actually being powered by the USB. There's nothing coming out the battery, and that's being charged by the Adafruit Power Boost. If I was to take the charger out, the motor stays off until I press the button again. There's also a feature on this Power Boost that if the battery was to go below, I think it's 3.3 volts, an LED on this comes on, but that's also wired back into the Arduino, and if you have a low power scenario, again kills the motor completely. So that's just a little look at one of the projects that I've been looking at. Thank you for watching. You can find me at Machine Shop UK on Facebook, Instagram and Twitter. And yeah, like, subscribe, share the videos, give me some comments on whatever, and yeah, I will see you in the next video. Have a good evening. Bye.